So representation 1 has an average length of 3 bits per message. And representation 2 has an average length of 2 bits per message. So on average, representation 2 is way more efficient. So if I were to store 1,000 students' grades using representation 1, or let's say, actually let's up the stakes a bit. How about 1,000,000 students' grades using representation 1? I'd use about 3 megabits. Using representation 2, I would use 2 megabits. So this saves 1,000,000 bits over that size of a file. How about a third representation? So I like this idea of, let's say, I'm really excited about this idea of representing shorter, or representing more likely events with shorter descriptions. So what I'm going to do is I'm going to take that to an extreme. So let's let this one be 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1. So by inspection, all of the code words in representation 3 are shorter or equal to the length of their corresponding code words in representation 2. So therefore this should have a much shorter representation than representation 2. What's the problem?
It's ambiguous.
It's ambiguous. So let's say I'm storing, what I'm going to do is I'm going to store these consecutively. So in other words, if I have 3 students and their grades are, let's say, C, C+, and B, using representation 1 it's obvious, so I know that each one takes up 3 bits. So just by inspection, I can draw the boundaries there and there. No problem with that. Using representation 2, my C is 0, my C plus is 1, 0, and my B is 1, 1, 0. So if I start reading left to right, I start with 0, and I'm like, okay, there's only one possibility for that. The only message that starts with 0 is this one. Then I have a 1, so I start by saying, all right, it must be one of these. But then I observe a 0, and I realize that the only one with a 1 in the first position is 0 in the second position is C+. So I can draw a line there. Similarly, 1, 1, 0, I realize that there's only one possibility there. On the other hand, this third representation, what do I have? I have 0, 1, 0, 0. Unfortunately, there are many ways to parse that. So even if I know in advance that there are 3 grades, one possible interpretation is C, C+, B. Another possible interpretation, can anyone see one?
C, A plus, and then C.
C.
I think it's an A plus. Yeah,
C, A plus, C, yes. So 0, 1, 0, 0, that's another possibility. A third possibility might be
C, C plus B.
C, C plus B, which is the correct one.
Oh, sorry, yeah.
Another incorrect one would be D, C, C, and so on. So you'd have many possible ambiguous interpretations. So that's a problem. What we want to avoid are these, I mean, obviously this is much more compact, but it cannot be uniquely decoded. So what we need is a code that is both compact and uniquely decodable. There's another possibility. What I could do is I could say, I could have say I have a third symbol, call it the comma. Like that. Now this is obviously uniquely decodable because every time I see a comma, then I can, every every time I see a comma, I can realize that there's a break there. Unfortunately, this now we don't have a binary set anymore. We have a ternary set because my set consists of my set of allowed symbols on the channel is 0, 1, and a comma. And it turns out this is not the most efficient way to use a third symbol. There would exist more compact representations than that. It will turn out, and we will show, that this representation 2, is the most compact possible. There does not exist any more compact representation that's uniquely decodable other than representation 2.